Hello everyone, welcome to the Modern Networking lecture series. This is lecture number 9. In the previous lecture, we concluded the lecture with the topic, the difference between the traditional networking and the modern networking. We saw that in case of modern networking, control and data, we have two different planes. Okay. Control plane, it does all the decision makings, and the data plane, it just does the forwarding work. So this is the SDN architecture. Okay, as seen in this particular SDN architecture, we have this we have the data plane. At the data plane, we have the virtual as well as the physical switches. Okay. The nodes, we can say it can be router or switch or any other. Then we have the control plane. As we can see, this is the control plane. So at the control plane, we have the SDN controllers. Then apart from this, we also have the application plane, where we have various applications running over it. So we have the network applications, business applications, and security applications. So these are the three planes. We'll be studying them in detail. So between the control and the data plane, we have the southbound API, the application programming interfaces. So one of the example of a southbound API is the open flow. So this particular API, we can say it is the logical connection between the two planes. Then in order to connect the application plane with the control plane, we have the northbound API. So REST is it is not actually an API, but it gives some constraints which must be followed. So this is REST between the application plane and the control plane. Okay, various other APIs are also suggested. So this is the architecture of the SDN. Okay. Now, what are the characteristics of SDN? So we have some characteristics of SDN as we can see here. The first one, the control plane is separated from the data plane. This is one of the important characteristics as compared to the traditional network. In case of traditional network, control and plane and data plane, they are not separated. They are situated on the same media. Okay. So here we have the data plane devices become simple packet forwarding devices. So the data plane devices, whatever the data plane devices may be, they may be router, they may be switch, they have just simple operation of packet forwarding. Then the next point, the control plane is implemented in the centralized controller or set of coordinated centralized controller. So at the control plane, we have the controller. It may be one or it may be more than one, where they are coordinating, and it may happen that one of the controller may have many number of switches or many devices under it. Then the next is open interfaces are defined between the devices in the control plane and those in the data plane. So we have this APIs. Okay. So to facilitate the communication between the two planes, we have the open interfaces, okay, which are the APIs. As we can see for the southbound API is between the control and the data plane. Okay. Then the network is programmable by applications running on top of the SDN controllers. So we can have various applications running over the SDN controllers, as we have seen here. Various applications. We have network applications, the security applications, the business applications which are running over the controllers. Then the last point, the SDN controllers present an abstract view of the network resources to the applications. So here abstract means what? The finer details, they are hide. Okay, they are not seen by the applications which are running on the application plane. Okay, they are not concerned with what type of switch and who is the manufacturer, who is the vendor of the switch. So this all the views they are not seen by the applications. So this is one of the features, that we get an abstract view of the whatever resources at the data plane would be. Okay. Then this SDN and NFV, we have various standards, and there are various bodies who make up the standards. So we have various organizations which are looking into the aspects of SDN and NFV. So a number of standard developing organizations are looking at the various aspects of SDN. These three are these are the main contributors. The first is the Internet Society. Number 2 is ITUT, that is International Telecommunication Union, Telecommunication Standardization Sector. Then we have ETSI, that is European Telecommunication Standard Institute. So these three are the key contributors with respect to SDN and NFV. Now with respect to Internet Society, we have two groups. The two most active groups within the Internet Society are this IETF, that is Internet Engineering Task Force. Then we have IRTF, so this is Internet Research Task Force. Okay, so ISOC, this is the Internet Society, is the coordinating committee for internet design, engineering and management. So we have these various organizations, and their aim is to have a particular standard which can be followed throughout. Okay, and the main aim is to make it as open interface so that anybody can contribute. Okay. This IETF, with respect to the Internet Society, it works in this particular areas, that is interface to routing systems and service function chaining. And this IRTF, it has published documents with respect to SDN. Okay, it reflects the current approaches regarding the SDN layer architecture, and it also provides a useful discussion of the southbound API and other specific APIs. Then we have ITUT. So ITUT has recommended the Y.3300 framework for SDN. We'll study this in detail in the coming sessions. So they have recommended this Y.3300 for the SDN framework. So this particular framework, it is a valuable framework for standards development. Okay, so this it gives a high level architecture of SDN, the definitions, the objectives, high level capabilities. All the requirements are provided by this particular framework. So this is the importance. Then we have 4 ITUT study groups. They have created 4 ITUT study groups, and they have some related activities, like we have SG13. So this is for future networks, which includes of course cloud computing, mobile and next generation networks. Then we have SG11, which is actually this is for signaling requirements, protocols and test specifications. Then we have SG15, which is concerned with the transport, access and home networks. Okay, then we have SG16, with respect to multimedia. So this group is evaluating OpenFlow as the protocol to control multimedia packet flows. Okay, so this OpenFlow is also one of the API. There is a southbound API. Then with respect to this ETSI, so ETSI has taken the lead role in defining standards for NFV, that is the network function virtualization. So this ETSI's network function virtualization provided set of specification for NFV. So they have provided this specifications regarding the NFV. These specifications, they include the architecture, NFVs, about the architecture of NFV, the infrastructure, service quality metrics, management and orchestration, then the other and some other things. Okay, this is for with respect to NFV. Then we have industry consortia. So many of the industry people, they have come together to define the standards. So we have a number of consortium which involved in development of SDN and NFV standards. So here we have Open Networking Function, ONF. Then we have Open Data Center Alliance, ODCA, and we have Alliance for Telecommunications Industry Solutions. So industry people have also come up for making the standards. Okay. So this ONF is an industry consortium dedicated to the promotion and adoption of SDN through open standards development. The most important contribution is the OpenFlow protocol. So this OpenFlow is one of the very important contribution of Open Networking Foundations. This is the southbound API. Okay, and this open flow protocol is the first standard interface specifically designed for SDN. So this open flow is the API which is used between the control and the data plane. Then we have ODCA. This consortium of leading global IT organizations is dedicated to accelerating adoption of interoperable solutions and services for cloud computing. So this is actually related with respect to cloud computing. So ODC is also defining requirements for SDN and NFV cloud deployment. Then we have the Alliance for Telecommunications Industry Solutions, that is ATIS. This provides the tools necessary for the industry to identify standards, guidelines, and operating procedures that make the interoperability of existing and emerging telecommunication solutions, products and services available. So this is concerned with this particular part. Okay, so we have apart from this we also have others, but we have just discussed the three important ones. Then Open Development Initiative. So there are a number of other organization bodies apart from the which we have discussed, which are of course not official bodies, and these organizations, they are user created and they are user driven and have a particular focus. So a number of such groups have become active in SDN and NFV. Now some of them are as follows. We have the Open Daylight, then we have Open Platform for NFV, and we have the Open Stack. Now with respect to Open Daylight, so Open Daylight is an open source software activity under the auspices of the Linux Foundation, and all the member companies of this particular Open Daylight, they provide resources to develop SDN controller for a wide range of applications. And this Open Daylight has also supports network programmability through southbound protocols and also a bunch of programmable network services. The first release of this Open Daylight was actually called Hydrogen, and the second one was the Helium. We will study this in detail in the coming sessions. And we have Open Platform for NFV. So this Open Platform for NFV is an open source project which is dedicated to acceleration the adoption of standardizations of NFV elements. And this Open Platform for NFV establishes a carrier grade integrated open source reference platform. Okay, and then this also ensures consistency, performance and interoperability among multiple open source components. And we have finally the Open Stack. Open Stack is of course an open source software project which aims to produce an open source cloud operating system. Okay, and we have this open source. It provides the multi-tenant infrastructure as a service. Okay, and it aims to meet the needs of public and private clouds regardless of size. Okay, so that the implementation becomes much easy and it is easy to scale. Okay, and one of the OpenStack project is the Neutron. Okay, and it is dedicated for networking and provides network as service to other OpenStack services. So that's all for this particular session. Okay, thanks for watching.